I used to think I understood reality. I mean, we all do, right? We trust our senses. We trust physics. We trust that the universe follows rules we can comprehend. But what if everything you thought you knew about reality is a lie? Over the next 10 minutes, I'm going to show you 8 facts about our universe that will completely break your brain. And I'm not talking about fun trivia. I'm talking about phenomena that challenge the very foundation of what we think is possible. Each one builds on the last, escalating from the quantum scale to the cosmic, and by the end, you'll see reality differently forever. Let me start with something that even Einstein couldn't accept: quantum entanglement. Here's what happens. You take 2 particles, entangle them, then separate them by billions of light years. When you measure one particle's state, the other particle instantly, and I mean instantly, reflects a correlated state. No signal travels between them. Nothing moves through space. It just happens. Einstein called it spooky action at a distance because it seemed to violate the cosmic speed limit. Nothing can travel faster than light. And here's the thing. He was right to be disturbed by it. Now, you might think this means we've found a way to send information faster than light. We haven't. The correlations are there, but you can't control them to transmit a message. What's remarkable is that experiments called Bell tests have confirmed this over and over again. The universe really does allow particles to be connected in ways that defy our intuition about locality and realism. You see, either the particles are influencing each other instantaneously across space, or reality isn't as real as we thought until we measure it. Both options break your brain. Now let's go deeper. Quantum superposition says that a particle doesn't just exist in one state. It exists in all possible states simultaneously until you observe it. The most famous illustration is Schrodinger's cat. A cat in a box with a quantum trigger is both alive and dead at the same time, until you open the box and look. It sounds absurd because it is absurd at our scale, but at the quantum level, this is exactly how particles behave. The thing is, this isn't just a philosophical puzzle. Superposition is the foundation of quantum computing, quantum cryptography, and the double-slit experiment where a single photon goes through 2 slits at once. The measurement problem asks, what counts as an observation? When does the universe decide which state to collapse into? We still don't have a complete answer. Some interpretations say consciousness matters. Others say decoherence with the environment is enough. Either way, the universe exists in a fog of probabilities until something forces it to choose. And that's deeply unsettling. Here's another one that defies logic: quantum tunneling. In classical physics, if a ball doesn't have enough energy to roll over a hill, it stops. But in quantum mechanics, particles can pass through barriers they shouldn't be able to cross, like ghosts walking through walls. This isn't science fiction. It's how the sun works. Nuclear fusion in the sun's core happens because protons tunnel through the electromagnetic repulsion barrier. Without tunneling, stars wouldn't shine, and we wouldn't exist. But let's be clear. This isn't magic. Tunneling happens because particles are described by probability waves, not solid objects. There's a small but non-zero probability that a particle on one side of a barrier will appear on the other side. The metaphor of ghosts through walls is useful, but it's not literal teleportation. Still, the fact that particles can defy barriers in ways we can't at our scale shows just how strange the quantum world really is. And this effect powers everything from the transistors in your phone to radioactive decay. Now let's scale up to the cosmic. Black holes are regions where gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. But here's where things get weird. Stephen Hawking showed that black holes emit radiation and eventually evaporate. The problem: if a black hole evaporates completely, the probability. Didn't make the sentence Solutions and information as some physicists think information synthesis and physicists the debate is still raging, but what's clear is that black holes sit at the intersection where our two best theories, quantum mechanics and general relativity, break down. And that means our understanding of reality itself is incomplete. In the late 1990s, astronomers made a discovery that stunned the world. The universe isn't just expanding, it's accelerating. Distant supernovae were dimmer than expected, which meant they were farther away than they should be if expansion were slowing down. Something is pushing the universe apart, and we call it dark energy. It makes up about 68% of the total energy in the universe, yet we have no idea what it is. And here's the kicker. Space itself is expanding faster than light in distant regions. That doesn't violate relativity because it's not objects moving through space. It's space itself stretching. There are competing models. The cosmological constant, Einstein's biggest blunder, fits the data but doesn't explain why its value is what it is. Dynamic field theories propose that dark energy changes over time. But honestly, we're in the dark. The fact that the dominant component of the universe is completely mysterious should terrify and excite you. Because it means the cosmos is far stranger than we ever imagined, and the fabric of reality is being torn apart faster every second. Let's talk about neutron stars. When a massive star dies in a supernova, its core collapses into a sphere about 20 kilometers across, but with more mass than the sun. The density is so extreme that a single teaspoon of neutron star material would weigh about 1 billion tons. Gravity crushes protons and electrons together into neutrons, held up only by neutron degeneracy pressure. The surface is a crystalline crust of iron nuclei, and beneath that, neutrons flow in a superfluid state. Pulsars, rotating neutron stars, sweep beams of radiation across space like cosmic lighthouses. And then there are magnetars. These are neutron stars with magnetic fields a quadrillion times stronger than Earth's. If a magnetar were halfway to the moon, it could erase the data on every credit card on Earth. Starquakes on magnetars release more energy in 1/10 of a second than the sun emits in 100,000 years, producing gamma-ray flares we can detect across the galaxy. Only about 30 confirmed magnetars exist, but each one is a reminder that matter can be crushed and twisted into forms that defy everything we experience in daily life. Most planets orbit stars, but rogue planets don't. They've been ejected from their solar systems, flung out by gravitational interactions, and now they drift alone through interstellar space. Estimates suggest there could be billions of them in our galaxy, possibly outnumbering stars. These worlds are cloaked in eternal darkness, with no sun to warm them, no day-night cycle, just the faint glow of distant stars, and yet some might harbor life. If a rogue planet has a thick atmosphere or geothermal heat from its core, subsurface oceans could remain liquid for billions of years. We've detected a few using gravitational microlensing, where the planet's gravity bends light from a background star. But most remain invisible, silent travelers in the cosmic void. So, here we are. From quantum entanglement, where particles ignore distance, to superposition, where reality exists in multiple states, to tunneling, where barriers mean nothing, to black holes, where information may vanish, to dark energy ripping the cosmos apart, to neutron stars crushing molecules. Every single one of these facts challenges what we think is possible. The universe isn't just it defies intuition and understanding. That's what makes it so beautiful. Because every time we think we've figured it out, it's what makes it so beautiful. Because every time we've figured it out, reality reveals we're standing on the edge of understanding, drop a comment below and tell me which one broke your brain. And if you want more universe-shattering truths, hit that subscribe button, because we're just getting started. The cosmos has more secrets, and I'm going to keep pulling them into the light. The universe isn't just strange.